Welcome to The Explainer. Today, we're diving into two really fascinating database systems, OODBMS and ORDBMS. They were both born out of this need to handle the messy, complex data that just doesn't fit into neat little boxes. So let's get right into it.
So let's start with the basic problem, right? Think about a modern video game. You've got a character. That character isn't just a name in a table. They have an inventory full of items, a tree of skills, and relationships with dozens of other characters. It's all interconnected. And that kind of data looks a lot less like a simple spreadsheet and a lot more like a complex web of objects, the very same kind of objects that programmers work with in their code.
Now, for decades, traditional relational databases were the gold standard, and for good reason. They are absolutely fantastic for structured data. Customer lists, sales records, that kind of thing. But when you try to force those complex objects, like the ones from languages like C++ or C#, into simple rows and columns, well, it can get really clunky and unnatural. This created what a lot of developers call an impedance mismatch. And that mismatch is what drove the need for brand new solutions.
Okay, so let's check out the first solution. This was a pretty revolutionary idea at the time. The thinking was, instead of forcing our programming objects into a databases world, what if we built a database from the ground up that thinks and acts just like an object-oriented program?
And that is the absolute core idea of an OODBMS. It treats data exactly as it appears in your application, as an object. And remember, an object isn't just data. It has properties, like a car's color, but it also has behaviors or methods, like a start engine function. It's all bundled together into one neat package.
So here's the crucial part. An OODBMS basically speaks the same language as the application. Instead of having to look up a customer ID in one table to find their orders in another, it just connects the customer object directly to its order objects. It does this using a unique pointer, which is called an object identifier, or OID. This creates this seamless, super fast bridge between your app and your database, which is just perfect for navigating those crazy complex data webs we were talking about earlier.
But starting completely from scratch is a huge ask, especially when the relational model was already so powerful and so well established. So what if you could kind of get the best of both worlds? And that brings us to our second solution, one that builds on what was already there.
An ORDBMS is a hybrid. Think of it as an evolutionary step forward. It takes that familiar, super robust world of tables, rows, and columns and just extends it, giving it new powers to understand and work with objects. You get to keep the solid foundation and just add new features right on top. And this really illustrates the whole strategy here. Don't throw the baby out with the bathwater. An ORDBMS keeps the stability and the incredibly powerful query language, SQL, that relational databases are famous for, but it enhances them. This means developers can store more complex data types right alongside their normal, traditional tabular data.
All right, so we've got two very different philosophies for solving the exact same problem. Let's put them side by side so we can really dig into the key differences and how they actually work.
At the highest level, you can really think of it as a revolutionary approach versus an evolutionary one. One started with a totally blank slate, designed just for objects, while the other adapted a proven, existing model to tackle a new challenge.
Okay, this table really gets to the heart of it all. The most critical part here, look at data storage. ODBMS stores data as objects. ORDBMS stores it in tables. That single difference changes everything. It directly impacts relationships. ODBMS links objects directly with those OIDs we mentioned, which is lightning fast for complicated lookups. Meanwhile, ORDBMS sticks to its relational roots, using traditional foreign keys to link tables. This right here is the core of their entire design philosophy.
And this comparison brings the real-world trade-offs into sharp focus. Take a look at the language row. ODBMS integrates right into languages like C++, which can make coding feel totally seamless for developers. But ORDBMS leverages the immense power and familiarity of SQL, and that is a massive advantage. And that leads us to the last row, query efficiency. For your simple table-based queries, the ORDBMS is almost always going to be faster and more efficient because, well, that's what its relational core was literally built to do.
So after all this comparing and contrasting, why does any of this actually matter? Well, for developers, for architects, and for businesses, picking the right model can have a huge impact on performance, how fast you can build things, and how well your application scales. So really, it all comes down to this. What's the job at hand?
If you're building a brand new system completely from scratch, and it's centered around these deeply interconnected objects, an OODBMS might be the purest, highest performing way to go. But if you're evolving an existing system and you just need to add object capabilities without throwing away your stable relational foundation and all the tools that come with it, an ORDBMS is almost certainly the more pragmatic, logical choice.
Ultimately, neither one of these models is inherently better than the other. They're just tools, and each one was crafted to solve the challenges of how we represent our increasingly complex digital world. In a way, they're just reflections of the problems we're trying to solve.
And that's really the question to leave you with. As our applications and our data get even more complex, will one of these models finally win out? Or does the future belong to some new kind of hybrid that we haven't even imagined yet? Thanks for joining us for this Explain It.